Okay, so we have one more titration problem in our ALEKS homework 3, calculating the pH at the equivalence point of a titration. So let's tackle this one. We have a weak acid and a strong base, and we are going to calculate the pH at the equivalence point. HClO3 plus KOH, which we're just going to write as OH minus, keep it simple, OH minus. We have ClO minus and H2O. And because this is a titration, we need to do our ice table in moles. So our first job is going to be to calculate how many moles we have of all of these things. For the HClO, here's our volume and molarity. So we're going to go the molarity 0.5008 times the volume 0.25 liters. Our initial moles are 0.1252. Hydroxide, same thing. We have, this time we can't calculate the initial moles. We are at the equivalence point. At the equivalence point, the moles of acid are equal to the moles of the base. So because we're at the equivalence point, we know that those two are going to be the same initial moles. That's what that means. And so we have no products initially. This is a strong base, so that means we're going to react totally to completion. 0.1252 is our X, 0.1252. And when this reaction is over, all that we're going to have is 0.1252 moles of this ClO minus. The ClO minus is then going to start its own equilibrium with water, and it is going to recreate some of that HClO, and it's also going to make some hydroxide, OH minus. So we need to make another ice table to look at how much OH minus is produced from our 0.1252 moles of ClO minus. Now this time we have no idea how much of it's reacting, because this time we are in equilibrium, so we have no idea. 0.1252 minus X, which we assume is just 0.1252, and X. We got to watch out. This is moles. So we better, before I forget, we better divide that by our total volume and figure out what the molarity is. Our total volume is 0.25 liters. That's this one right here. Plus the volume of the hydroxide. Volume of the hydroxide. Got to find a place to calculate that. I'm going to scoot this 0.25 liters over. The volume of the hydroxide, we know from the original ice table, we know we have 0.1252 moles of hydroxide. We're going to use molarity like a conversion factor. Moles per liter. The molarity is 0.2042 moles per liter. So that gives us 0.1252 divided by 0.2048. That gives us a volume of 0.613 liters and a total volume of 0.863 liters. And a molarity of 0.1451. We need to solve for X in order to be able to calculate the pH. To solve for X, we have to write an equilibrium expression. This is going to be a Kb because we're producing hydroxide. This Kb is going to be X squared over 0.1451. Remember here we're using molarity. We're not using moles. We're using the molarity. And what is our KB? We don't have that. We have a pKa. They're just making us jump through all the hoops. We have a pKa. It is 7. I think that says 7.5. 7.5. So that means our pKb is 14 minus 7.5, which is 6.5. And our Kb is 10 to the negative pKb, 10 to the negative 6.5. So 10 to the negative 6.5 is equal to x squared over 0.1451. 10 to the negative 6.5 times 0.1451. Take the square root. X is very small. It is suspiciously small. It makes me nervous. It's so small. That is our hydroxide concentration. We can calculate the pOH from that. The pOH is the negative log of the OH minus. .67, and from that we can get the pH. 10.33. Let's see what we get. 10.33. Whoa, thank goodness.